DGPS, our Differential Global Positioning System, is an enhanced version of the traditional Global Positioning System, GPS. It improves accuracy by correcting GPS signals for various error sources. Here are its components, applications, and usefulness in land surveying. Components. 1. Base station. A stationary GPS receiver with a known fixed position. It accurately determines its location and broadcasts correction data to roving GPS receivers. 2. Roving receiver. A portable GPS receiver that is used in the field for land surveying. It receives signals from satellites and correction data from the base station to calculate precise positions. Applications. 1. Land surveying. DGPS is widely used in land surveying to precisely measure property boundaries, create topographic maps, and conduct construction and engineering surveys. 2. Agriculture. It helps farmers with precision farming by mapping soil variations, optimizing crop planting, and guiding automated farming equipment. 3. Marine navigation. DGPS aids ships and boats in safe navigation, particularly in coastal areas and busy waterways. 4. Aviation. Aviation authorities use DGPS to enhance aircraft navigation accuracy, especially during landing approaches. 5. Geodetic surveys. For precise geodetic control networks used in mapping and monitoring Earth's crustal movements. Usefulness in land surveying. 1. Increased accuracy. DGPS significantly improves positioning accuracy compared to standard GPS, making it ideal for precise land surveying tasks. 2. Real-time corrections. DGPS provides real-time correction data from the base station, reducing the impact of satellite signal errors, atmospheric conditions, and clock discrepancies. 3. Efficiency. Surveyors can work more efficiently and complete projects faster due to the improved accuracy, reducing the need for rework. 4. Cost savings. By reducing the need for physical markers and ground control points, DGPS can lower surveying costs. 5. Versatility. DGPS is adaptable for various surveying applications, including boundary surveys, construction layout, and topographic mapping. Overall, DGPS is a valuable tool in land surveying, offering increased accuracy, efficiency, and cost-effectiveness for a wide range of applications in the field. GPS, Global Positioning System, is a satellite-based navigation system that allows users to determine their precise location on Earth. Here's how GPS works and some key differences between GPS and DGPS. How GPS works. 1. Satellites. The GPS system consists of a constellation of 24 or more satellites orbiting the Earth. These satellites continuously broadcast signals that include information about their precise locations in the current time. 2. Receiver. A GPS receiver, such as the one in your smartphone or GPS device, picks up signals from multiple satellites in the sky. To calculate your position, the receiver needs signals from at least 4 satellites simultaneously. 3. Triangulation. The GPS receiver uses the signals it receives to calculate the distance, range, to each satellite based on the time it took for the signals to travel from the satellites to the receiver. This process is called trilateration. 4. Position calculation. By knowing the distance to multiple satellites and their precise positions in space, the GPS receiver can calculate its own latitude, longitude, altitude, and speed. Orbits. GPS satellites are in medium Earth orbit, MEO, typically at an altitude of about 20,200 kilometers, 12,550 miles, above the Earth's surface. They are arranged in multiple orbital planes to ensure global coverage. Differences between GPS and DGPS. 1. Accuracy. GPS. Standard GPS can provide position accuracy within about 5 to 15 meters, 16 to 49 feet, under normal conditions. DGPS. DGPS improves GPS accuracy significantly by correcting GPS signals, offering sub-meter to centimeter level accuracy, depending on the setup. 2. Corrections. GPS. Standard GPS does not apply any corrections to its signals and relies solely on the data from satellites. DGPS. DGPS employs a network of base stations with known positions to monitor GPS signal errors caused by factors like atmospheric conditions and satellite clock inaccuracies. It then sends correction data to DGPS receivers in real time, enhancing accuracy. 3. Applications. GPS. Standard GPS is suitable for many applications, including navigation, mapping, and location-based services. However, its accuracy may not be sufficient for high-precision tasks like land surveying. dgps. dgps is primarily used in applications where high accuracy is crucial, such as land surveying, precision agriculture, marine navigation, and geodetic surveys. In summary, GPS is a global navigation system that provides accurate positioning for various applications. dgps is a specialized system that improves GPS accuracy through real-time corrections and is particularly valuable for tasks requiring high precision. The measurement of dgps, differential global positioning system, data involves collecting precise positioning and correction information using specialized GPS receivers and base stations. Here's an overview of the steps involved in measuring dgps data. 1. Base station setup. Establish a stationary base station with a known and precisely surveyed location. This location serves as a reference point for differential corrections. 2. Base station operation. The base station continuously collects GPS signals from satellites overhead and calculates its own highly accurate position. 3. Correction calculation. The base station compares its calculated position with its known surveyed position. Any discrepancies or errors are determined. 4. Correction data generation. The base station generates correction data based on the errors it identified. This correction data typically includes corrections for satellite clock errors, atmospheric delays, and other sources of GPS signal error. 5. Correction broadcast. The base station broadcasts the correction data to nearby dgps receivers in real time. This communication can be done through radio signals, cellular networks, or the internet, depending on the setup. 6. Roving receiver setup. A dgps rover receiver, which is a portable GPS receiver, is set up in the area where precise positioning is needed. 7. Roving receiver operation. The rover receiver collects GPS signals from the same satellites used by the base station and receives the correction data broadcast by the base station. 8. Position calculation. Using the correction data, the rover receiver applies corrections to the GPS signals it receives from the satellites. This improves the accuracy of its position calculation. 9. Data logging or real-time use. The rover receiver can log the precise positioning data for later analysis, or it can provide real-time accurate position information for various applications, such as land surveying, agriculture, or navigation. 10. Data integration. dgps data collected from multiple rover receivers can be integrated and processed to create accurate maps, conduct surveys, or perform other geospatial tasks with high precision. Overall, the measurement of dgps data involves the continuous monitoring and correction of GPS signals in real time to achieve highly accurate positioning, making it valuable in applications that require precision and reliability. A traverse in surveying is a series of connected survey lines or measurements used to determine the positions and distances between points on the Earth's surface. It's a fundamental technique in land surveying and geodetic surveying. There are various software options available for studying and analyzing traverse data. Here are a few popular ones. 1. AutoCAD Civil 3D. AutoCAD Civil 3D is widely used in the field of civil engineering and land surveying. It provides tools for creating, editing, and analyzing survey data, including traverses. You can import traverse data, adjust it, and generate reports and drawings. 2. Trimble Business Center. Trimble Business Center is a comprehensive software package for surveying and geospatial professionals. It supports the management, processing, and analysis of traverse data, including adjustment and reporting. 3. MicroSurveyCAD. MicroSurveyCAD is a survey and design software that includes features for handling traverse data. It allows you to input, adjust, and generate reports for traverse measurements. 4. TopCon Magnet Office. TopCon Magnet Office is designed for survey and construction professionals. It offers tools for importing, processing, and analyzing traverse data to create accurate survey plans and reports. 5. Carlson Survey. Carlson Survey is a software solution that's tailored for land surveyors. It provides features for entering and processing traverse data, as well as generating survey reports and drawings. 6. Civil 3D and Carlson Surveyor, for field data collection. Some software solutions are used in combination with field data collection tools like total stations and GPS equipment. Civil 3D and Carlson Surveyor, for example, can work in tandem with field instruments to gather traverse data and then process it in the office. When studying traverse data, these software tools allow you to input raw measurements, adjust traverse data to improve accuracy and closure, generate reports detailing traverse measurements, closures, and errors, create drawings and maps based on the traverse data, integrate traverse data into larger surveying and mapping projects. The choice of software may depend on your specific needs, the type of instruments you're using, and your familiarity with the software's features. Surveyors often select software based on their preferences and the compatibility with their surveying equipment.